So chapter 7.1 is going to be an introduction to hypothesis testing. So hypothesis testing is going to be a process that uses sample statistics to test a claim about, in this case, about the population mean mu. So in the questions, we're going to be given a claim about the mean for the whole entire population, and we're going to test the validity of that claim given sample statistics. So to test the population parameter, in this case mu, we always need to start with the null hypothesis and the alternative hypothesis. So the null hypothesis, which we can denote with an h sub 0, is going to contain a statement of equality. So it's going to either be less than or equal to, greater than or equal to, or equal to. The alternative hypothesis, which we can denote as h sub a, is going to be the complement or like the opposite of the null, which will not have equality, so either greater than, less than, or not equal to. So there's only going to be 3 possible combinations for how these hypotheses get set up for each one of these questions. So the k value here that's going to be in all of these is going to be the hypothesized mean. It's going to be the number from the question that we're doing. So the first setup that we can have is for the null. We can either have the mean is greater than or equal to the value from the problem, or if that's the case, then that means the alternative would have to be the opposite. So if the null says greater than or equal to, that means the alternatives has to say less than. For the second setup, if the null says the mean is less than or equal to a number, that means the alternative has to say the mean is greater than the number. And the third possible combination is going to be if the null says the mean is equal to the number, then the alternative has to say not equal to the number. Okay, so we'll see what this means in these next examples. So let's state the null hypothesis and the alternative hypothesis for each one of these examples. So the first one says a car dealership says the mean time for an oil change is less than 15 minutes. Okay, so what I like to do here is first go over to the claim. So the claim says the mean is less than 15. So using our notation, we would say mu is less than 15. So when we're setting up the null and the alternative here, so there's the null and there's the alternative, we have to think which one of these is mu less than 15. That one has to be the alternative because there's no equality there. So if that's the alternative, then that means the null has to be mu greater than or equal to 15. So it's the exact opposite or the complement of the alternative. So also just label the claim. The claim was the alternative. Okay, and then for B, we have a company claims that the mean life of its furnaces is more than 18 years. So the claim is that the mean is more than 18. So that means our claim is mu greater than 18. So when we're setting up our alternative and our null, mu greater than 18, once again, this has to be the alternative because there's no equality. So the alternative is our claim again. And if that is the alternative, then the null has to be mu less than or equal to 18. So once again, they're complete opposites. Okay, and then the last one for these examples is a school says that the mean number of students in extracurricular activities is 121. So here we have the claim is that the mean is 121. So this time it's going to be mu is equal to 121. So this time the claim is the null. So the null is mu equals 121. We knew that was the null because there was equality. So if that is the null, then the alternative is the opposite, which is mu is not equal to 121. Okay, Okay, so those are essentially the three possible setups for these hypotheses. Pretty much is always going to be the first step for these questions that we'll be doing in the previous sections, or rather in the following sections. So when we actually do these longer problems in the later chapters, we're going to start by assuming that the null hypothesis is true, regardless if it's the claim or not. And we're trying to gain enough statistical evidence to see if we can reject the null. So with that being said, there's two conclusions that can be made for these problems. Either we can reject the null hypothesis, or we fail to reject the null. If we reject the null hypothesis, that means we would be accepting the alternative. If we fail to reject the null, that does not mean we can accept the null hypothesis. So we either reject the null and accept the alternative, or we fail to reject the null. So failing to reject the null does not mean that we accept the null. Okay, so the kind of terminology is a little bit confusing there, but it's really important. And since we're going to be working with a sample here, and we're trying to come up with conclusions about the population, we could come to the wrong conclusions. So there's two types of error here. Type 1 error is when if we reject the null and it's actually true. A type 2 error is if the null is not rejected when it is actually false. So those are just the types of names for the errors that can be made for these types of questions. So what we're going to be doing is finding the probability, which we are going to be calling the p-value. We're going to find the probability that the given scenario can occur, and this p-value is going to be an area. It's going to be an area under the curve. So we're finding the p-value that a given scenario from the question can occur. We're going to be comparing it to a significance level alpha. Alpha here, the significance level, is the maximum allowable probability of making an error. So this means that the larger the p-value, the more evidence there is to reject the null hypothesis. And this is because we start by assuming the null hypothesis is true. So a small p-value means there's a small probability that the given outcome in the question can occur, meaning we can reject the null. So it would be saying that there would be a small probability of the null happening, meaning we can reject it. So the smaller the p-value in general, the more evidence there is to reject the null. Okay, so what we're going to be doing, like we mentioned, is we assume the null hypothesis is true, and we're testing the alternative hypothesis against the null to see if we can reject the null. So there's three kinds of tests that we're going to be doing. The alternative determines the type of test. So we have all of our three setups here. We have, for the first setup, we have the null is mu greater than or equal to k, and the alternative is mu less than k. This is a left-tailed test, and it's a left-tailed test because of the alternative is mu less than k. So left-tailed because of the alternative being less than. So we're going to be doing this for the z distribution and the t distribution. So for now, I'll just put down z here as if it's the z, because that's what we'll be doing first. So what we're going to be doing is finding an area, and that area is going to be the p-value. So left-tailed test means an area to the left of the z-score. Okay, and that's going to be one of the z-values that we find, but we'll mention that. I'm not going to label it because we'll mention it in the next section. The next one for a right-tailed test. A right-tailed test is going to be the setup if the alternative says greater than, and that's going to be the area to the right. So we shade in that area to the right, and that is our p-value. And lastly, for the third possible setup for our hypotheses, we have a two-tailed test. So two-tailed is going to be when mu is not equal to the hypothesized mean. And what this means for the area being shaded in, it's going to be the area to the left of negative z and the area to the right of positive z. So two-tailed meaning left and right. So each one of those shaded in regions represents 1/2 of the p-value. So added together, it equals the full p-value. And we'll see when we're in the next section, when we're actually doing these problems, to find that p-value, we just need to find the area to the left of negative z and multiply that by 2. Okay, so let's do a couple examples here. So for each claim, state the null and alternative, and then determine whether the hypothesis test is going to be left-tailed, right-tailed, or two-tailed. So these are the same examples as before. So a car dealership says the mean time for an oil change is less than 15 minutes. So when we set this up, we said that that was the alternative as the claim. We said that was mu less than 15, which makes the null mu greater than or equal to 15. So when we're determining if it's left, right, or two-tailed, we have to look at the alternative, and more specifically, we have to look at if it's less than, greater than, or not equal to. So since that is just less than, that's a left-tailed test. So on the curve, it's going to be an area to the left, and that area to the left is going to be that p-value. Okay, and then for the next one, a company claims that the mean life of its furnace is more than 18 years. So we said that the alternative was the claim in the question is mu greater than 18, which makes the null mu less than or equal to 18. So based on the alternative, since that's mu greater than 18, it is a right-tailed test. So that means when we are filling in what the area is, or where the area is, that's going to be an area to the right because it's right-tailed, and the area inside there is going to be the p-value. Okay, and then for the last one here, we have a school says the mean number of students involved in extracurricular activities is 121. So we said that that was the null. We said mu equals 121 is the claim, and the alternative is mu is not equal to 121. So based on the alternative, not equal to, that means a two-tailed test. So that means the area is going to be to the right of positive z and to the left of negative z. So the p-value is going to be the area shaded in here, where 1/2 of the p-value is right there and the other half is right here. And once again, we'll see in the next section, finding the total area, we just need to find one of them and multiply by 2. Okay, so for forming a conclusion here, the conclusion that we make for coming back to the hypotheses, if the p-value that we find is less than or equal to the significance level alpha, which is given to us in the problem, that means we reject the null and accept the alternative. If the p-value that we find, which once again is just the area, if the p-value is greater than the significance level, then we fail to reject the null. Okay, so those are the only two conclusions that can be made for these hypotheses. And once again, for an explanation kind of why this is, since we start by assuming that the null hypothesis is true, a small p-value, small probability, means that these results are unusual, which means we have to reject the null since we assumed it was true. Okay, so then in the next sections, we'll actually use all of this introduction stuff and do some of the longer problems.